طيب بسم الله الرحمن الرحيم. So we start chapter 9, IP security. So at the beginning, we'd like to give some high-level picture about the context of معلش لسه الصوت برضه يعني لسه شوية بس أحسن كتير يعني. الله يسلمك. I will give like some high-level picture just to understand the context of IP security in relation to what we have studied so far. So in network access security, what we have talked about is the fact that we have a device or a workstation, and this device wants to have access to a network. So there is an entry point in the form of access point or switch or whatever, and then what the objective here was to kind of authenticate and secure the point-to-point port between this device and the entry point of this network, just to make sure that this device is secure when it's connected to the network. And when we say secure, this means that whatever information flowing here, it's hidden or there is some confidentiality, so there is some resistance to any kind of eavesdropping. And at the same time, this device is actually authenticated, which means that anything that comes from this device, we have non-repudiation and we can prove that this is coming from that device and so on. Okay, طيب. From a protocol data unit point of view, this means that the information flowing here, we have the protocol data unit, okay, which is like the payload, and there is the header. This header is for data link layer header, right? So this is a DDL header, okay? So securing this physical port or logical port in the case of wireless, this means that this payload is encrypted, is hidden, and there is some kind of MAC, okay? But this DDL header is exposed, as we said. I mean, so the security service works on top of the protocol in that layer. Okay, this is very important to understand. Okay, again, if you starting from here, if you don't have network one fresh in your mind, you will be in a big trouble. So we'll start to talk very detailed about the networking stack. You need to have complete perception and good understanding of the protocols in each layer. Okay. So the DDL header is exposed, okay, because the switches, they need to process this header, including the MAC address and so on. Type. So having said that, why do we need IP security then? So if this, we're talking about security from the bottom, talking about security from the network access layer, why do we need higher layer security? Why do you think we need IP security, if that's the case?
It's on the next layer.
Yeah, the network layer, yes. Why do we need security from the network layer if everything is secure from the bottom?
So I cannot send many attacks on this IP.
How do you send? ما هو احنا بنقول ان هو الديفايس نفسه.
Like DOS.
Yes, but the device itself is secure. Okay, how can you send this?
I can flood it with the messages.
You mean from outside?
From outside.
But flooding this from outside, from other sources, right? If these other sources are connected to the network, they need to be connected the same way. They need to be authenticated, and so the DDoS attack can happen. Yes, it can happen actually in every layer, including even the physical layer. صح? So what is the DDoS attack from the network point of view بقى? What did we call it? حد فاكر؟ We called it a network injection. Okay, so we can inject the network with some information that can corrupt the network infrastructure, right? So, so in a way, securing the device itself does not mean securing all the applications all the applications and processes running on that device. Okay? So some of these applications might be secured from the application point of view, using, for example, TLS. We'll study TLS. Okay? But there is no guarantee that all these applications, they use some secure services. Some of these applications may not actually, so like some applications may in fact use HTTP instead of HTTPS, in which case these applications are not secure. Okay, so what is the implication of this? The implication of this is that these applications might be source of injection of network level messages. Okay? How? Because this port is secure. Yes, just the fact that this port is secure, but this the information flowing here does not distinguish the application level traffic. It doesn't look at that. Okay? So it's very much agnostic to the type of traffic coming from the application. It doesn't see that. Okay? So all we will see is that, yes, this application is unsecure, so the messages will flow, will go through the port, it will be encrypted and everything, and then the high-level message, okay, can get into the network and can perform some kind of network injection. Network injection includes some kind of a route updates, مثلا. I can send from unsecure application, I can send route updates to the routers, okay? If I send route updates to the router, I can corrupt the entire routing tables. Okay, so I can perform attack from the network layer even if the port is secure. Okay, so IP security came with the perception of the main objective is to try to secure the network infrastructure. Okay, so the network infrastructure, including all types of messages, okay, that uses IP or ICMP or any kind of network layer protocol, from injecting anything into the network infrastructure. This is the main objective. واضحة البيكتشر دي؟ Okay كده؟ طيب, so having said that بقى, how do we do this? How do we achieve that objective? That's what we need to talk about. All right, so IP security was actually developed by IETF, or by the IAB, or the Internet Architecture Board, and it identifies key areas for security mechanism. So we need to secure network infrastructure from unauthorized monitoring and control and network updates. ماشي? So we need to secure end user to end user traffic, because network access control does not distinguish the traffic. Okay, it's very much traffic agnostic. It doesn't see what type of traffic. It cannot really categorize the traffic, neither based on the user nor based on any kind of addressing or something like that. So it doesn't see. So anything that's flowing in that port is undistinguishable. So of course, the standards themselves, they include securing IP version 6 and IP version 4. Of course, IP version 6 is much, much more complicated, as we have studied in Network 1. And also the security services on top of IP, they kind of leverage the features of the underneath protocol, as we will see in a minute. So any features in the IP version 6, it can be leveraged, and it kind of affects the security service. And at the same time, for IP version 4, as we will see. طيب, what are the applications of IPsec? Why do we need IPsec? So IPsec provides the capability to secure communications across LAN and private and public WANs, which means that we can, in the IP level, of course, we're talking about source to network, okay, or network to network, صح? So that's what we have studied, right? So IPsec tries to secure either from one user to a particular network, or from a network to network. So user to a network, this is what we all use on a daily basis almost, by using VPN. So VPN, in fact, uses IPsec. Okay, so if you want to connect to a remote network and you use VPN, this will allow you to be part of that network virtually, even if you are remote, like even if you are across the content, in another content. ماشي? Same thing, network to network. So, for example, in the past, if مثلا Apple or Google, they have different offices geographically distributed. In order to secure that, they need to dig cables, basically. Okay. So if you have multiple offices owned by the same organization, okay. So one thing to do to secure that is to, in fact, dig some kind of a physical cables between the offices to build your own infrastructure. So this way you make sure that this infrastructure is actually secure, and it secures the communication between the offices, okay? Is this actually scalable? No, of course. So this is not feasible, especially nowadays. ماشي? So what is the other alternative? Well, between these offices, there is already the internet infrastructure, صح? طيب, so in that case, can we use the internet infrastructure directly? Of course not, because internet is public network and it's inherently insecure, right? So what IPsec tries to achieve in this whole picture is to try to build some logical tunnels. So using IPsec, we can build logical tunnels over the public infrastructure. Okay? So this tunnel will allow us to secure all types of traffic coming from this network going into the tunnel. Okay? While actually distinguishing this traffic. So we can, from the network perspective, we can provide different experience to the different types of traffic. That's the good thing about IPsec. Not only does it secure within the tunnel, but it can, in fact, provide different behavior for each type of traffic. So here, as we will see in a minute, we can categorize the traffic based on a user, based on IP address, based on different criteria. And for each type of that traffic, we can, in fact, provide different behavior, whether it goes into the tunnel, bypasses the tunnel, blocks the entire traffic, things like that. ماشي? This is VPN, right? This VPN, as we said, VPN uses IPsec. Okay? So examples like secure branch offices connectivity over the internet. So this is this particular example that we talked about. Or secure remote access over the internet. So you want to access the services in your enterprise network, okay? But you are traveling. So again, you can build a tunnel between your workstation and the remote network using also VPN. But we will see we have different modes in that case. We have the transport mode, we have the tunnel mode. So depending on the scenario that we're talking about, we can use different modes. And there is implications back to each one of them that we need to discuss. So if you try to access your network infrastructure from a remote location, you can also use IPsec to build a tunnel between your workstation and the network. So in the IP level, we talk about, again, host to network or network to network. Okay, so these are the typical. Establishing extranets. So extranets, what is the definition of extranet? What is extranet? What's intranet type? This is intranet that we talked about. This scenario is the intranet, right? It's a virtual private network built over an insecure infrastructure like internet. Okay, what is the difference? The slight difference between intranet and extranet is that if you want to secure two networks owned by the same organization, that's intranet. Extranet, if this is Apple and this is Google, that's it. And the two networks are owned by two different organizations. So if Apple wants to talk to Microsoft, they also need to use secure network or secure communication. So this is the extranet. واضح? or enhancing electronic commerce security. يعني electronic commerce اللي هو e-commerce. طب احنا بنستخدم e-commerce on a daily basis. Every one of us, we shop through Amazon. يعني. So what does IPsec have to do with Amazon? Well, Amazon is not just a website. Amazon is a whole ecosystem that, in the back scene, there is supply chain, there are tons of suppliers. There is, basically هنا we have extranets between Amazon website and the different suppliers, and we have inventory, we have this, we have that. So we have extranet of different entities and different offices behind this e-commerce. It's not just a website. Now we see a website. The user interface is just a website, but there is whole system behind it. ماشي? So the principal feature of IP is that it can encrypt and or authenticate all traffic. So in that case, it can be traffic specific بقى, مش traffic agnostic هنا. Okay, so we can classify the different types of traffic and we can give different behavior to the different types of traffic. Thus, all distributed applications like remote login can be secure. Okay, and the security here is to try, the main objective here is to try to secure the network infrastructure from any harm that can happen through these types of traffic. Okay, that's the main objective of IPsec. So this is how it looks like. This is like sort of the system model. So here we have private network, and private network here like internal network, okay, which is protected by like a firewall or a router here, okay, like مثلا our home network. Inside our homes, we don't have to use actually IPsec. We don't have to use security per se, right? It's a private network. That's why here, if you see this symbol, this is unprotected IP traffic. So this is unprotected IP traffic because it's the internal network, right? And here as well, same thing, okay? But if you want any host from here to communicate with any host on this network, then we have to go through this tunnel. This is a network-to-network tunnel, okay? So this tunnel uses IPsec. So the service that this tunnel provides is that any traffic, any information flowing here, we have to have like certain policies, we'll talk about this, which categorizes this traffic, and based on that, it goes with certain behavior through the tunnel so that it can be communicated to the other end, okay? So this is the network-to-network security. So there is also, as we said, the remote host security where we can build that tunnel from the host to the network. Okay, so the tunnel can be from a network to network or from a host to a network. If it's from a host to a network, then all types of applications here, they flow into that tunnel. And again, we can categorize the different traffic coming from different applications based on user, based on IP address, and so on and so forth. And based on that, we can provide different behavior for that traffic. From a protocol level point of view, here we talk about the tunnel mode format. We'll talk about the tunnel mode in a minute. So here, from a protocol point of view, we have IP payload, and we have the IP header. Why do we say original IP header? The original IP header, this is the IP header that comes with the payload. So we did not update that. We did not, in fact, modify this in any way. How do we provide security on top of this? There are two ways. Here, we highlight the tunnel mode. For the tunnel mode, we keep the original IP. So if a host here wants to communicate with a host here, okay, then the source IP will be this IP, right? And the destination IP will be this IP. صح كده? This is maintained in the IP header, okay? So if we talk about the tunnel mode, what we do is that we keep the original header as is, and we add on top of it, or this is like we add to it like some security header. We'll see about the content of this security header. So this security header secures traffic that goes through that tunnel here, okay? But going through this tunnel, if we use this header, this means that the original IP address with the payload will be encrypted, صح? And also, we add to this as well the ESP trailer, which includes the MAC, صح? So this means that we provide confidentiality through encryption, and we provide MAC for message authentication, ماشي? And non-repudiation. طيب, but this means that the original IP with the payload will be encrypted, right? So when the traffic flows here we have many routers here on the way, right? Do these routers have access to that header? Of course not, because the header is encrypted. Okay? So in that particular mode, what we do is that in addition to the security header, we have to add a new IP header. This IP will not have the source and the destination. No, we'll have the source address here and the destination address here, at the beginning of the tunnel and the end of the tunnel. Okay? So these IPs can be used by the intermediate routers to route traffic through the tunnel. واضحة دي? Okay? So the original IP address will maintain source IP and destination IP. Okay, so in addition to that, we have to we call it new IP address, or sometimes we call it outer IP address. This outer IP address provides the IP address for source and destination at the beginning and end of the tunnel to allow routers, and this is exposed, of course. This will not be encrypted. Okay, and this will allow routers inside the tunnel to route traffic towards the end of the tunnel. Once it reaches here, خلاص, security will be removed and it will become like a public IP. So this part will be decrypted and then it will be sent over the other destination network. واضح كده الأمر؟
New IP with the two headers will be added in the firewall, on the firewall.
Yes, here. This means that IPsec is running here. Yes, IPsec will be running here on this router. Okay? And we will see. We have an IP session between the two routers. So some negotiation has to happen. يعني في شغل كتير. So we'll have to talk about the details. ماشي كده؟ طيب, so some of the benefits of the IPsec. When IPsec is implemented in a firewall or a router, it provides strong security that can be applied to all traffic crossing this perimeter, while it actually distinguishes that traffic. So it's traffic. It's not traffic agnostic in that case. It can distinguish and categorize that traffic. Traffic within a company or work group does not incur overhead for security-related processing. So inside the internal network, the traffic doesn't need to know whether IPsec is running on the router or not. So IPsec running on the router is totally seamless and transparent to the internal network traffic. They don't need to know, right? And they don't need to have any specific handling or treatment because IPsec is running. It's totally transparent. So IPsec in a firewall is resistant to bypass if all traffic from outside must use the firewall. So in fact, one of the services of IPsec is actually is that traffic coming in, one of the behaviors is that you can bypass the traffic from going into the tunnel. I can do that. So that's one of the ways, right? But I have full control in that case. I can control whether this traffic can be bypassed or whether this traffic has to indeed go through the tunnel, and we'll see the different cases, why we need to do this, why we need to do that. IPsec, of course, in terms of protocol level, it works on top of IP and underneath TCP and UDP, صح? So it's in between these layers. And so it's transparent to all applications. As we said, all applications, they don't actually see anything underneath. So it's very much transparent to all applications. So there is no need to change any software. So all the application services running on the network or on a host, they don't need to have any built-in functionality for IPsec whatsoever. They don't need to see that. They don't need, like, for example, any software upgrade, any modification to the software. They don't need this. IPsec can be transparent as well to the end users. Hence, there is no need to train users on security mechanisms. So I can build a tunnel, okay, and users, they even don't know that their traffic is actually going through a tunnel. And in fact, that's what Ooredoo does. So Ooredoo, they have tunnels, okay, in their network infrastructure. Okay, and the traffic can in fact can have certain policies, okay, for the different types of traffic. Some of the traffic can go through the tunnel, some of the traffic can be throttled, some of the traffic can be bypassed completely, go to the internet, things like that. But we don't see that, and we don't even need to know about this, right? So it's totally transparent to the users. So IPsec can provide security for individual users if needed. So again, the traffic can be categorized based on username, based on source address, destination address, based on MAC address, based on anything. So we'll see that. This is useful for off-site workers and for setting up a secure virtual sub-network within an organization. So this is used for private intranet and intranets. So IPsec can play a vital role in routing architecture required for internetworking. So in that, IPsec can be used to secure all these types of messages. So a route advertisement, which is part of dynamic routing protocols. So route advertisement comes from, it needs to know that this is coming from an authorized router. So routers, they authenticate themselves to each other. So any kind of messages in the routing level, it's actually authenticated, and we know exactly where it's coming from. A router seeking to establish layer network adjacency, layer hello messages. Hello messages between the routers with each other is also authenticated, and routers, they need to make sure that this is coming from authorized router. So that also uses IPsec. A redirect messages comes from a router to, so even if a router wants to redirect messages, it needs to also make sure that this is coming from an authorized router, or a route updates, okay? So route updates cannot be forged in that case because we use MAC, okay, to achieve integrity and the message authentication, or authenticating each message to know where it's coming from. So in a nutshell, all type of routing layer messages, whether it uses IP or ICMP, they are all secure through IPsec. Type. This is the standard documents developed by IAB or IETF. Okay, so this is IPsec documents. In fact, the IPsec standards are specified or detailed in multiple documents. The most important ones are the encapsulating security payload, ESP. So ESP is the most important one, and the authentication header. So authentication header, from the name, is used for authentication, right? So we need to provide authentication. We'll see that through IKE. We'll talk about this. We talked about this before. Infrastructure key management. So AH is used for authentication, and we have the encapsulating security payload, which is used for confidentiality and MAC and other services. So these are the most important documents, right? In addition to that, we have the architecture document, where we'll talk about the architecture in the next slide, which kind of lays out the overall architecture of IPsec and how the IPsec services interact with each other. So we'll see that in a minute. And of course, IKE, which is the Internet Key Exchange, which is used for authenticating the users or the traffic coming from the network. So we'll talk about this. So this is laid out in a separate document. And of course, all the cryptographic algorithms, okay, and why and how they are used, and in what level of services is actually laid out in one of the documents, and also other standard documents which describe, for example, the policies. We'll talk about policies. We will kind of talk about all these aspects of the standards in the following slides. Okay, so here we talk about the policies. What are the policies based on which you categorize the user and you give different behaviors to different user traffic? Okay. So as we said, there are two modes. There is the transport mode and there is the tunnel mode. So the transport mode is used for securing host-to-host communication. Host-to-host communication. So so for that particular purpose, we have, of course, we have the IP payload, okay, and we have the IP header. The IP header, so for in the transport mode, what happens is that because we have host-to-host secure communication, the IP of the source and the destination, they are the same even within the tunnel. So the tunnel is built between two hosts to secure the communication. Okay? So in that particular case, what usually happens is that we add ESP header, okay, after the payload. ماشي? And optionally, we'll talk about this, we have also AH header. Okay? And then we have the IP header exposed. It's not, so when we say ESP header, this means that this part will be encrypted. صح? And the AH header maintains the integrity and the authentication. So AH header, in fact, adds also here, there is trailer as well, which includes the MAC. Okay? So the encryption will include the payload, and then the authentication for the MAC will include the integrity information and the message authentication codes, usually for this entire part. Okay? And in fact, for AH as well, sometimes we will see that. Sometimes we even include part of the IP header for the authentication. And we'll talk about why. Okay? So this is the transport mode.
The trailer with the MAC address, that part is not encrypted.
لا التريلر لا طبعا هو التريلر هو includes بالضبط cannot be encrypted. طيب, so this is the transport mode. In that case, the IP header, there is only one IP header, okay, which is the original one, and in that case it's exposed. Because as the IP for the source and destination for the tunnel is the same for the source and destination of these two hosts. So in that case, we maintain the IP header and we put the security headers in between, which means that the security will work on top of IP. ماشي كده؟ So that's the transport mode, and it can only be used for host-to-host secure communication. For the tunnel mode, it's used for all the other combinations, host to network or network to network. ماشي? So for host to network or network to network, what happens is that if we use, like, if we have a host and we have a network, so we build a tunnel between that host and the network, and of course the IP at the end of the tunnel will be different from the destination IP, right? Because of that particular reason, what happens here is that we have the IP payload, right? And we have the original IP. Okay? So we add to that the ESP header, And optionally, I say optionally, we'll talk about this in a minute. Optionally, we can add the AH header. And then after that, we add the outer IP. This outer IP بقى will include the start and the end of the tunnel. واضح كده؟ And this outer IP is exposed and it's used by the intermediate routers to route message across the tunnel. So this is the transport mode. واضح الفرق بين الاثنين؟ This is the tunnel mode, yes. Okay, so this is the transport mode and this is the tunnel mode. So in that case, the IP, the original IP is actually encrypted. So no one sees that. Okay, so this is encrypted. Okay, and then this whole part is authenticated, and of course there is the trailer as well, اللي هي الماك. Okay, so this is for the transport, the tunnel mode. So here the transport mode provides protection primarily for the upper layer protocols and for TCP and IP and so on, and typically used for end-to-end communication between two hosts. This is the main keyword. ESP in transport mode encrypts and optionally authenticates IP. ليه بقى بنقول optionally? Because in IPsec version 1, what happens is that the standard creates two separate documents and both are mandatory to be used اللي هم ال ESP and ال AH. ESP is used for encryption, AH is used for authentication. Okay, and explicitly mentions that this is used for encryption, this is used for authentication, and you have to use both. Okay, IPsec version 2 came with the perception of, why complicate things? We can use ASP both for encryption and authentication, right? Which means that we don't need AH. We don't need AH header, okay? But they realize that they cannot remove completely AH header for backward compatibility. So they made it optional. So in IPsec version 2, okay, you can optionally use AH for authentication, or you can use ESP for both encryption and authentication. واضح كده؟ So that's why I say this part is optional. I can remove this and use ESP for both encryption and authentication. So removing removing AH does not mean removing authentication, because authentication has to happen, right? The question is, who will do it, whether ESP or AH? It can be done within one header, okay? If I can use one header for both, of course, this is more simplified and less overhead, right? So that's the perception of IPsec version 2. طيب, the tunnel mode provides protection for the entire IP packet, including the original IP. So even the source and the destination IPs are not seen by anyone. A number of hosts on the networks behind firewall may engage in secure communication without implementing IPsec. So if I provide a tunnel mode, all the traffic coming into the tunnel, they don't actually see that there is a tunnel, coming up. They don't need to know, right? So it provides seamless protection for all the traffic that is coming through the tunnel. ESP in tunnel mode encrypts and optionally authenticates the entire inner IP packet, including the inner IP header, اللي هو الinner ده اللي هو ده. Okay? And AH in the tunnel mode authenticates the entire IP packet and selected portions of IP header. ده اللي احنا كنا بنقوله. Selected portions of even this part. Okay? So when I calculate the hash, well, message authentication code is a hash and it's encrypted, صح? So when I calculate the hash, I can in fact also ensure the integrity of the header, of the IP header, but I cannot encrypt it. Why you cannot encrypt it? Because routers, they need to use it for processing. So that part is clear, but we can ensure the integrity of the IP header, صح? That does not affect the processing of the routers. So we can do that, Okay, why do we say بقى اللي هيجاوب لي على السؤال ده يبقى very why do we say portions of the IP header and not the entire IP header؟ ايه؟ لا هو اي بي هيدر ملوش علاقه بهوست بورشن وغير هوست بورشن. الاي بي هيدر لو فاكرينه include some fields كده من ضمنهم طبعا السورس اي بي والديستنيشن اي بي وشويه حاجات كده يعني صح؟ I can use the integrity to also ensure the integrity of the IP header, but I cannot calculate the hash based on the entire IP header. I cannot do that. Why بقى؟
Because some values will be changed at the router.
اللي هي زي ايه بقى؟
Like the ports, I think that the IP.
البورت.
The ports will be changed.
مفيش بورت. مفيش بورت في الموضوع. البورت ده TCP. There is no port number. ايوه.
The distance, the path, the routing table, maybe it will change sometime.
What exactly changes in the IP? يعني in other words, some parts of the header can be manipulated, and this is by design يعني. This is by design. It cannot be perceived as a violation to the integrity.
Subnetting.
Like what بقى؟
Subnetting.
Like ايه بقى؟ ايوه like TTL or hub count مثلا. This can it needs to change, and this is by design. It needs to change. صح؟ So I cannot include this in the hash. What else? If I use NAT, صح؟ If I use NAT, network address translation, in that case the IP address needs to be translated, right? So the IP address may change, and that's by design, right? So I cannot calculate the integrity based on the entire IP header. But there are certain parts that's fixed no matter what. So these parts of the header I can include in the integrity check.
So the thing is like specific parts.
Yes, specific part. ما هو قال بيقول هنا اهو selected parts, selected portions of the IP header.
So they are fixed.
Yes, of course. And they are mentioned, highlighted in the standard. We don't need to explicitly memorize them, بس يعني بس we know why selected parts, not the entire part. Okay. We need to include certain parts and integrity, yes, of course, because we do need to also maintain the integrity of the header. And that does not affect router processing. Routers should not, complain about this, right? They should complain if it's encrypted. We're not encrypting the header, right? But we can try to also ensure the integrity of certain parts of the header, but not the entire header. We cannot do that. واضح كده السبب؟ So this difference between transport mode and the tunnel mode, and that's بقى how what is the relationship between AH and the ESP. So this is so the remaining slides, they kind of highlight IPsec version 2 mainly. There is version 3, by the way, but we're covering mainly IPsec version 2. So in IPsec version 2, AH here is actually optional. You may in fact use AH for authentication. So in the transport mode, AH can be used to authenticate the IP payload and selected portion of the header. Okay? In the transport, of course, in the transport mode, we have only one header, صح? اللي هو one IP header يعني, and it's exposed. Okay, so we cannot encrypt it, but we can authenticate the selected parts of that header. For the tunnel mode بقى, AH authenticates the entire inner IP address, اللي هو original IP address, plus selected portions of the outer IP address كمان. ماشي؟ So ESP is used بقى for encryption. So here we encrypt the IP and any IP version 6 extensions. This is a bit tricky بقى. And IP version 6, if you remember, there is IP extensions here refer to, if you remember in IP version 6 in network 1, we discussed what we call next header. there is a field called next header. So in fact, IPv6 supports nested headers, okay? So you can have مثلا IPv6 encapsulated within IPv4, encapsulated within ICMP header. So you can in fact have multiple headers, okay? So in each header we have what we call next header, right? So we can have multiple headers. So in fact, these extended headers can be encrypted in that case. Okay? So the IPv6 extensions can be encrypted. Not the actual IP header cannot be encrypted, but the extensions can be encrypted. So for example, if you have ICMP over, sorry? Here it's not optional. If you use IPv6 and you have IPv6 extensions, okay, this means that the main IPv6 header is not encrypted. ماشي? But all the extension headers can be encrypted. The idea here is that routers, they need the main IP header for routing. خلاص, I'm giving you the IP header. I'm not encrypting that IP header, right? But if the IPv6 supports what we call extensions, so the extensions can be encrypted without affecting, again, the processing of the router. So for the tunnel mode, it encrypts the entire IP packet, including the inner IP header. There is ESP with authentication. So in that case, we don't have any AH. خلاص. We use ESP both for encryption and authentication. So in that case, this combines both, here and here, simply. يعني. واضح كده? Any questions here? طيب, this is about the architecture. This is the overall picture of the architecture of IPsec. Okay, so this is the whole architecture. So it starts here with, so now we're talking about basically a tunnel. So imagine that there is some kind of a tunnel, okay, and there is some kind of a traffic coming in, and traffic, in fact, we call this outbound. We call outbound يعني getting into the tunnel. And inbound معناها inbound to the network, معناها getting out of the, although this is يعني, to me it's like opposite, yeah, it should be the other way around, but this is the terminology used in the standard. So that's how it looks like from an abstract point of view. So it actually starts from the security policy database. Security policy database. Okay? So the security policy database runs at the beginning of the tunnel and at the end of the tunnel to try to identify the behavior that this traffic should encounter at the outbound and the inbound. So traffic coming in, the first thing it hits the security policy database. In the security policy database, we have to identify that traffic and identify the policy corresponding to that traffic. ماشي? There should be an entry in the database that highlights that for this type of traffic, you need to provide that behavior. And that behavior could be block the traffic completely, get the traffic into the tunnel, okay, which means this traffic will have to use some security context, okay, or bypass this traffic from the tunnel, send it through the public network. So why on earth do we need to do this? We'll talk about some scenarios where we can in fact do this, and in fact we have to do this. So building the tunnel does not mean that every single traffic has to go through the tunnel. We'll talk about some scenarios why. So in any case, we start with the security policy database. Any traffic coming in, it should have an entry in the security policy database. What if there is no entry? This traffic will be blocked in that case. ما فيش بقى default route, huh? It's not like a router. We have default. No. Here, if a traffic does not have a match in the security policy database, it gets blocked by default. Type. If there is an entry, then we identify the behavior. Based on that, we refer to what we call بقى security association database. So from the security policy database, we have a behavior. The behavior would be, okay, so secure that through the tunnel, which means get this traffic into the tunnel. So in that case, we have to point to a security context بقى, or security association. This security association maintains بقى all the keys for confidentiality, for this, for that. We'll talk about the details of each one of these. Okay? So going into the security association database, we grab the security context, all the keys, everything, and then we start to send the secure information through that tunnel. Okay? It goes back all the way to the other end of the tunnel, ماشي? And then at the inbound or getting out of the tunnel يعني, we have to also apply another security policy database, same thing. To know exactly at the end of the tunnel, what do we do with that traffic? ماشي? Sometimes you have to block the traffic at the inbound. We'll see يعني, we'll see some scenarios of this. طيب. So for securing that traffic, we need a security association, which is the security session بقى, which maintains all the session keys and everything. So this is a security association pair. And as we can see, the security association pair here is one for each direction. It's separate. So you need to have two security associations to secure the traffic on this side or on this side. That's why it's two different lines here. So why do we have one-way security association? We'll talk about this. ماشي? طيب. If we need to secure the traffic, right? But there is no security association in the security association database. ماشي? This means that the traffic is coming in. We know that we have to secure it, but there is no authentication yet for that particular traffic. In that case, we need to engage IKE to start authentication process, اللي هي user authentication. مش بقى message authentication, اللي هو user authentication. User authentication has to go through the IKE. We'll talk about this maybe next lecture. ماشي? And the outcome of this, as we said before many times, the outcome of this is اللي هو master key. Achieving a master key. From this master key بقى, we can drive all the session keys اللي هي it's being used as part of the security association. ماشي? So here security association talks about message authentication. If there is no security association, this means that the user authentication has not been done, so I have to engage with IKE to start the user authentication process. ماشي? So this is the overall picture or the architecture. So we need to talk about each part of this. So a question here, why we didn't talk about policy database and security association database for the case of network access control? And in fact, when we talk about TLS, also we don't have anything like this. We don't have security association database. We don't have security policy database. We don't have this. We don't have this, in fact. So why here we talk about database? So the idea here is that in the IP security level, this is the only level where we provide different behaviors for different types of traffic. We have to distinguish at the level of the traffic. When we talk about TLS, we'll talk about application to application, because TLS is transport level. We'll talk about application to application. So there is one point here, one point there. There's one type of traffic from here to there. That's it. Okay? When we talk about network access control, it's actually, again, device-to-device communication. So we secure at the device level. We don't have to distinguish traffic in any way. This is the only level where we can provide different security levels or different security services for different types of traffic. So we need, okay, based on the incoming traffic, okay, we have to categorize it and select one security association for that particular traffic. ماشي? So that's why we need to have a database, because having the tunnel does not mean it's one service. لا, it's we have to provide at the traffic level, not at application to application or device to device. ماشي? So that's why we need to have database for the case of. طيب, the security association بقى is a key thing in IPsec. It's a one-way logical connection. Why بقى one way? Why the security association is one way? This is again coming from the inherent features of IP. And this is the يعني ايه بقى the distinction for network security. You have to have the perception of the protocol when we talk about security services, because the security service is affected by the underneath features of the protocol. So IP is inherently connectionless and unreliable. صح? Because it's connectionless, there's no connection. When we will talk about TLS works on top of a TCP. And TCP is connection oriented. So there is bidirectional communication. فهتلاقي في one security association, or طبعا they don't call it security association, they call it something else, but the security context is one per connection bidirection. But here we cannot do that because IP is in fact connectionless. And it's unreliable as well, right? So that's why we have to provide security association for one direction, and the security association on the other direction has nothing to do with this. ماشي? So it has to be one way for securing the communication going into one direction. طيب, if any IP packet in any IP IP packet, the security association is uniquely identified by what we call by a destination address and what we call the security parameter index. So in the security policy database, if the traffic can have a match, then we get two things. We get the destination address of that traffic, and we get what we call the security parameter index. Security parameter index is in fact the primary key for the security association database, which points to which security association will be used for that particular traffic. ماشي? So the security parameter index is the primary key for that points to a particular security association in the security association database. Assuming there is one, if there is no security association, this means that I need to perform user authentication through IKE, as we will see later. So the security parameter index is the primary key. And there is the IP destination address. Together, they will identify that this traffic has a particular behavior, and based on that, we have this security association entity. And we have the security protocol identifier, which is like a flag, whether we have AH or ESP security. Okay, so this security association is for AH. By the way, there is different security association for AH and ESP. Okay, so there is security association for AH and there is security association for ESP. So in the security association itself, there is a flag, okay, that refers whether this is for ESP or AH. If it's for ESP, this means that this is used for mainly for confidentiality. If it's for AH, this is mainly used for message authentication. طيب, so security association by itself contains طبعا the security parameter index, we talked about it. This is the primary key. ماشي? So it's identifier for the structure of the security association. ماشي? طيب, what else بقى? We have sequence number counter. هو sequence number, why did we use sequence numbers في الheaders? As part of security for ايه؟ برافو عليك. For replay attack. طيب ما احنا بنستخدم sequence number for replay attack, صح? But here بقى you will see we have sequence number, we have sequence counter overflow, and we have anti-replay window. All of these three are used for replay attack. Why not just simply the sequence number? ليه بقى؟ Why do you think we need all these three for the case of IP? Again, it's related to the inherent features of IP, right? Because IP is inherently unreliable. So packets flowing into the network, there is no guarantee they will arrive أصلاً. And even if they arrive, there is no guarantee they arrive in order. صح؟ طيب أنا دلوقتي if I get packet 1 and then packet 3, okay, and then packet 2, طب ده بقى replay attack ولا ده إيه ده؟ يعني ما هو مش المفروض إن المفروض ال packets are coming fresh. صح؟ Should I assume that packet 2 was in fact arrived late ولا ده replay attack ولا okay? So that's why it cannot one field is not enough for simply mitigating the replay attack. We need to have a window technique. And that's interesting because we know the window technique مثلا is used in TCP for what? The window technique can be used for TCP for flow control. صح? We used the window technique for TCP for flow control. Here it's used for security, which is an interesting dimension. Why? Because of the inherent features of IP being unreliable, it does not guarantee the delivery أصلاً, and even if the delivery is achieved, it cannot guarantee the order of that delivery. Okay? So we'll see how this window technique is used to mitigate replay attacks. Not used for flow control here, خالص. Because أصلاً IP does not need flow control, doesn't provide flow control, it's unreliable. Okay, and it's connection-less, so it doesn't have any flow control. So in addition to these, which are used for replay attacks, we have AH information or ASP information. And there is the lifetime of this security session. Why? Because, again, this is like session keys or temporary keys, so we need to have like certain lifetime after which we have to again go to the master key and you know renew all the security context based on the master key, صح? So we need to have lifetime, but also sometimes I can in fact invalidate a security association prematurely if I detect that there is like some kind of a compromise, يعني مثلا replay attack. يعني based on this window technique we can decide also that there is some kind of a compromise or there is some suspicious behavior that there might be some replay attack, in which case I can end this security association prematurely and I can engage in renewing this security association. So there is the IPsec protocol mode, whether it's a tunnel mode or transport mode or doesn't matter. This is about the path MTU. ال MTU دي stands for ايه؟ حد فاكر؟ ها؟ ايه؟ Yes, maximum transmission unit. This is used for what? حد فاكر؟ فاكر مثلا؟ Used for what? Yes, the maximum message size. Yes. What do I use it for بقى؟ ايوه اللي هو اسمه ايه؟ fragmentation. Okay, so I use maximum transmission unit for fragmentation. So يعني I expect some of you you don't remember قوي fragmentation يعني. So the idea of fragmentation is that again IP, as we say, is medium agnostic, so it can work over wireless, Ethernet, fiber optics, anything. So it's agnostic to the physical infrastructure, but there is something that affects IP when it comes to this physical infrastructure, which is this maximum transmission unit. So assuming that we have a network, and this network is Ethernet. What is the maximum transmission unit for Ethernet? It was like 1500 bytes. So this means that Ethernet supports up to 1500 bytes of frame يعني. Okay? So this frame gets طبعا it has the IP header. Okay? طيب. So we have a packet which has like 1500 bytes and including the IP header مثلا. طيب what if I go from Ethernet to wireless? Wireless due to بقى channel impairments, due to many things, we cannot provide مثلا more than 500 bytes. So in IP we studied the fact that from here to here we have to divide this into 3 different fragments, we call it. 3 different fragments. Okay? So from 1500 we go 500, 500, 500. Okay? So that's fragmentation, and sometimes we have to do it. Okay? طيب. What is the implication of this بقى on the tunneling or IPsec اللي احنا اتكلمنا عليه? Remember here, this packet is now ايه بقى؟ encrypted. ماشي؟ When we divide it into fragments, we have to provide headers for all these fragments. Providing headers, this means that the security header needs to be replicated وكده يعني. ماشي؟ So we're not saying that for IPsec fragmentation is impossible. It's not it's doable, but it's hard. It's affected by the fact that now we have security services and we have MAC, we have encryption, we have ESP header. So what do we do with these if we need to do fragmentation? So IPsec provides, in fact, some means for fragmentation inside the tunnel. Okay? But the common mode, okay, is based on trying to avoid fragmentation inside the tunnel. So how can we avoid fragmentation inside the tunnel? What we do is that inside the tunnel, we try to discover the maximum transmission unit across the entire tunnel. Okay, so if we have here 1500 and 500 and then 3000, okay, so while we are establishing the security association end to end, what we do is that we try to discover the maximum transmission unit. In that case, it's 500. And we store it in the security association. We store it in the security association. So this means that inside this tunnel, okay, even if you have Ethernet with maximum transmission unit of 1500, معلش خلي عليك شوية, we'll have to use 500 to avoid fragmentation inside the tunnel, because this will complicate the security services. واضح كده؟ ماشي؟ Any question with this? So this is what the path MTU is used for. It's used to try to avoid fragmentation inside the tunnel.
But the path is not always the same, so it will be calculated. Sometimes the path will be different up on the routing table to the shortest.
You mean, okay, that's a very good question. Because as we said, IP is unreliable, and part of this lack of reliability is that it does not even guarantee the route. So packet flowing from one point to another, they are not guaranteed to go through the same route. But the tunnel ensures the same path. So for the tunnel, you have to go through the tunnel, and the tunnel ensures the end-to-end path.
Even if one of the router is down and we have
One of the routers down, that's خلاص ما هتعمل ايه يعني. One of the
no,
Of course, one of the routers is down, خلاص, the whole tunnel is doomed. خلاص, the whole tunnel. When I say it's doomed, that doesn't mean that the traffic will be off. يعني you have to establish another tunnel بقى. You have to establish another security association and establish another tunnel end to end. عادي, ما فيش مشكلة. ماشي. So we'll have to go through the overhead of establishing that tunnel. So the VPN connection will be lost, and this happens, يعني, and we have to reconnect, which means establish another tunnel. When you establish another tunnel, you can go through different routes. You can go through different route and different set of routers and everything. ماشي كده? Any questions? we understand that each of these fields and what they do. Okay. طيب security بقى policy database. So for the security policy database, the means by which IP address is related to specific security association contains entries, each of which define a subset of IP traffic and points to an security association for that traffic. So in more complex environment, there may be multiple entries that potentially relate to a single security association. So multiple traffic may in fact use the same security association, ماشي? Or different traffics may in fact use different security associations. So again, this is up to the policy and how we arrange these policies. Each security association database entry is defined by a set of IPs and upper layer protocol fields. We call them selectors. These selectors may in fact be any combination of these: a source IP, destination IP, username, ماشي? Or any other fields. We'll see all these particular fields which can be part of these selectors. So we can define مثلا that traffic going from that IP to that IP uses that particular security association. Or any traffic going to that IP uses that security association. ماشي? So we can define the selectors in any combination of these. So these are used to filter outgoing traffic. معلش outgoing traffic معناها getting into the tunnel. In order to map it into a particular security association. So these are the selectors, or these are the different fields which can be used as part of these selectors. So it could be remote IP. So this actually remote IP may be a single IP or a subnet address that refers to a particular network. So the selectors can in fact use برضو ايه some اللي هو masking to provide set of IPs. So any traffic that goes to 128.kaza.kaza.anything.wildcard is actually will use this security association. ماشي؟ طيب. The local IP address, this may be برضو a single or a subnet. ماشي؟ طيب. Next layer header. So based on the header, so all TCP traffic may in fact use that particular security association. All ICMP traffic may be bypassed, مثلا. Okay, so this is the next header or next protocol header. Type the name here refers to the username. Okay, so even from the application level, we can provide from the application level, or local and remote ports. So in fact, here we can have access to the TCP port or the UDP port, and in that case, we can provide the selectors based on the port number or the username. So we can filter traffic based on the ports, which means the application, or the username, or the IP addresses. ماشي? So these are some examples for the security policy database. So these are some entries in the security policy database. So for example, any traffic that's coming from this local IP address on port 500, okay, and it uses the UDP, this in fact indicates that this traffic is IKE traffic. يعني إيه؟ يعني this is used for user authentication, which means it has to go through an uncontrolled port. معناها إيه؟ This traffic needs to bypass the tunnel. We cannot perform user authentication through the tunnel. ماشي? So user authentication has to bypass the tunnel. So this is one of the examples. برضو error messages like ICMP may in fact bypass the tunnel. For this is used to provide error messages between two routers. So if routers want to inform each other about some error message, for example, لو فاكرين اللي هو exceeding the hop count مثلا. A router decremented the time to live or the hop count and it becomes 0. So it needs to provide an error message. Okay, so this error message does not have to go through the tunnel. In that case, in fact, it should not go through the tunnel because it sends that to another router, so this needs to bypass the tunnel. So that's another example. Another example to bypass the tunnel, which is if we use TCP, the header field is TCP, and it goes through, مثلا, and it's coming from this IP address, going to any port, any remote IP address, or to a particular IP address. What is this port? حد فاكر؟ اللي هو ايه port ايه؟ 443 is used for ايه؟ HTTPS بالظبط. So if it's HTTPS, bypass. Why? Because the application is already secure. Why do you need to secure it? صح? If the application is already secure, the application itself is coming and it's secure already. Why يعني provide redundancy and provide also, because here IP, again, the objective is to secure the network infrastructure. So if the application is already secure, so what is the problem with this? So it's already secure. So I don't have to provide another level of security in that case. So that's another example of يعني bypassing the. So otherwise طبعا اللي هو this is the default behavior, which is to protect. There is also discard here. If the traffic is coming from that particular address to going to any subnets or something like this means that this traffic needs to be blocked. This might happen مثلا لو في ناس مثلا أو this على فكرة there are different behaviors other than these. It could be like throttle. There is a behavior called throttle. So congest that traffic, which means that you need to provide يعني less data rates for that particular traffic. And this happens, for example, with Ooredoo. I don't know if somebody encountered this. If you use WhatsApp on Ooredoo network, sometimes you see the voice is bad يعني. صح? But if you try to connect using VPN, you tried that? If you try to connect using VPN, the voice quality is perfect. Becomes perfect. Which is a little bit interesting because VPN, in fact, provides more overhead. So how come when I provide more overhead, the voice quality is better? But this is because of the fact that if WhatsApp traffic is coming normally, they usually throttle the traffic. Okay? They provide bad quality for that. And this is on purpose. It's by design. ماشي? So if you use VPN, your traffic will be hidden. خلاص. They don't see the header. They don't see the service. They don't see that you are doing WhatsApp or whatever. So in that case, it goes.
Does it affect also the images and files?
It can actually. It can do that. But I'm not sure if there is particular image service that gets مثلا throttled or blocked. يعني website, some websites مثلا. Some websites are blocked, and that's normal. ماشي. But if you use VPN, I'm not giving you ideas, but if you use VPN, it's hidden and okay. So there is also a discard. ماشي. So there are different behaviors. طبعا the protect one, which means that if this one is protected, then we need to provide اللي هو security parameter index, which points to the security association database to try to get the security association to use it for encryption and authentication and so on. ماشي. طيب, so this is the flow chart بقى for how to process an outbound معلش يعني this is again going into the tunnel. So the traffic is going into the tunnel. So the first entry point is to search for a match for that particular traffic using the selectors from the IP header, from TCP header, username, things like that. So we have all of this. And we try to search in the security policy database for a match. If there is no match, we discard. خلاص. If there is no match at all, ما فيش حاجة اسمها default route here. Actually, if there is no match, we discard. If there is a match, then we determine the policy. Maybe the policy is discard. So in that case, again, we go to discard. ماشي. And if the policy is bypass, this means we don't have to add ولا ESP header بقى ولا AH header ولا أي حاجة. خلاص bypass معناها send it over the internet normally. So forward to IP خلاص to send it in the normal way. If it's protected, this means that here we have the security parameter index, and it refers to a security association. So we have the security parameter index. In the security parameter index, if we look in the security association database and we find a match, okay, this means that here we have the security association. Here, actually, we may not have the security association. If we search using security parameter index in the security association database and we find a match, this means that we do have a match for a security association that we can use. So in that case, we add بقى ال SP header, AH header, before we forward it to IP. If we don't have a match, what does this mean? This means that the user association was not done. واضح? The user association was not done. So we have to engage بقى with the IKE to do the user association, to have a master key, and then from the master key we create the security association, and then we go to the other path. ماشي؟ ايوه. لا, a security association database runs on the router or on the node at the beginning of the tunnel.
Yeah, I know. When I'm connecting to another network, they have their own security policy database.
No, it has to be negotiated between the beginning of the tunnel and the end of the tunnel.
Yeah, but the same configuration, yeah, it has to be fixed. Or
لا, هو based on the traffic that's flowing, the entries in the security policy database needs to be synchronized between the beginning of the tunnel and the end of the tunnel. So these entries in the security policy database are not permanent. They are not fixed. Okay? When you try to connect or create a tunnel, okay, the policies gets entered in the security policy database, and this has to be synchronized between the router at the beginning and the router at the end. Once this VPN tunnel is dismantled, the entries may change. It needs to be re-established again when you try to create the tunnel in the future. So the entries are not permanent, are not fixed. So they have to be renewed and modified every time you try to create some VPN tunnels with a remote network or with a remote host. ماشي؟ لسه مش واضحة برضه؟ تمام؟ تمام. So this is the inbound traffic bar. It starts from the bottom here, from IP. So if the packet is coming and there is no ASP header or AH header, it's a normal IP packet. So in that case, we don't actually send it. This is at the end of the tunnel. We don't, in fact, send it right away to the upper layers. We don't do this. Why? Because there might be some injection traffic in the middle of the tunnel. Okay? So we have to go to the security policy database and make sure that this traffic is, in fact, should be bypassed. ماشي? To avoid any kind of attack in the middle of the tunnel. So we have to go to the security policy database, and in fact, if the policy is bypassed, then we send it up. So this is again at the end of the tunnel. That's why I say there has to be some synchronization between the security policy database here at the beginning and end of the tunnel. These are synchronized. ماشي? If it's not bypassed, then we discard. We don't actually send it. Don't forward it. If it's IPsec, then again, we go through security association database, which should have the security association that corresponds back to this ASP header or AH header to try to get all the keys stored and decrypt and verify the MAC and do all of this. And then we send it up. If there is no match, at this point, if there is no match, we don't do a user authentication. This is this is at the end of the tunnel. User authentication should have been done. ماشي? So we don't this would be a very naive action. Okay, so we engage for user authentication with iKey. No, we don't do that. This is at the end of the tunnel. So in that case, we discard right away. ماشي? So the last thing we discuss here is the anti-replay mechanism. Anti-replay mechanism here, as we said, is based on window technique. It's not based simply on one sequence number and that's it. Why? Because again of the inherent feature of IP being unreliable and connectionless. ماشي? So if we receive packets unordered, this does not necessarily indicate any replay attack. So for that we create what we call window size, and this window size is fixed. And typically in IPsec standards they use 64 packets. So why exactly 64 packets? Well, this is based on some experimental studies. They conclude that the unordered behavior of IP can be compensated within a window of 64 packets. So if I receive the worst case scenario, if I receive a packet here and I receive a packet here, 64 packets less, so maybe that's the worst case when it comes to IP being unreliable and the packets are unordered. ماشي? So this window, anything inside that window, I have to mark it as received or not received. Received معناها إيه؟ If a packet is received with a sequence number within that window, then I have to verify the MAC, of course. I have to authenticate the packet and everything. And then if everything is fine, then I mark this packet as received. Okay? Type. If I do this and the packet is authenticated and everything, but there is a flag that says that the packet has already been received, what does that indicate? Replay attack. That there might be some replay attack. Okay? But within the window, I can receive with any order. Type. If I receive a packet with a sequence number here, outside the window, I don't maintain whether the packet has been received or not. ماشي? If I receive a sequence number before the window, what do I do? برضو I have to declare this as possibly some possibility of replay attack. With the only exception بقى, if the counter overflow is set to 1. That's why we have this flag of counter overflow. Why? Counter overflow is 1. This means that we are recycling the sequence number. Okay? So this means that we have reached the end and we are going back to start from 0, 1, 2, 3, and so on. Okay? So having a sequence number, like for example, if I have here, this is مثلا now this is like 500, 501, 502. Okay? And then the overflow, the counter overflow is set to 1, and then the sequence number is coming with a sequence number of 2. What does that indicate? This indicates that this 2 is in fact is a new packet which is fresh after the 502. صح? Because the counter overflow indicates that we are recycling the numbers. It's like بيقولوا في العربية بيقول لك دي قلب عداد يعني. We are resetting the sequence. Okay? So this is the only exception. If the counter overflow is set to 1 and the sequence number is less, this means that this less number is in fact a new packet. So in that case, it's not to indicate a replay attack. But of course, if the counter overflow is set to 0 and the sequence number is like, for example, 5 or 30 or something, which means that it's outside and it's before the window, this also indicates it's possibly a replay attack. ماشي؟ طيب what بقى if I have a sequence number here 505? What does that mean?
Lost a lot of.
Hmm?
That means I lost a lot of packets.
Not necessarily lost. Not necessarily lost.
Multiple.
What do I do in that case? Hmm?
Some packets were transferred twice. Or
لا خالص. لا. This is a new packet. But it's outside the window.
I save it for when. If I got another 505, discard it.
لا هو شوف for any window technique ماشي there is a logic for what do you do before the window, within the window, and there is also a logic how to slide the window. ما هو window technique معناتها has to slide. So if you receive a packet after the window, this means if this packet is authenticated and it's verified, this is a valid packet. It cannot be a replay attack because it's a fresh packet. And in fact, this is an indication to you that you need to slide the window. When you slide the window, some of the packets inside the window may be received or not received or something like this. ماشي? So when you receive a packet here, for sure this is a fresh new packet. Or even if you receive a sequence number, low sequence number, but the overflow is 1, this means also that it's a new packet. So for these particular cases, you need to slide the window. ماشي؟ فهمنا logic? So these are the 3 cases for the window. And again, this window is because of the inherent feature of IP being unreliable and no guarantees for the order delivery.
this what can happen is both directions. Like maybe
Yes, of course.
some packets are just like the other side.
هو احنا قلنا for one direction it's independent from the other direction because we don't have the context of a connection here. We don't have the concept of a connection at all. Packets flowing in one direction are not related to the other direction. We don't have connection. It's not bidirectional in any way. Even the security association is different. It's separate. Okay. خلاص we'll stop here. كفاية كده. Yeah, stop.